Good afternoon, students.
Good afternoon, sir.
Good afternoon, sir.
Hi. Please put your attendance in the command window. Also, please inform other students to join the call. Till the last class, we have discussed columns and threads, in which we have studied different theories that include Euler's formula as well as Rankin's formula. Now, we are going to discuss theories of failure, how all the components, all the shaft, everything may fail. What are will be the reason for failure of shafts and other components? Bolt, nut, everything will be discussed in such a part. So there are 5 theories for theory of failure, and among them, now we are going to discuss the first one, that is Rankin theory. Comparing with last class, that is Rankin formula, it is not having any direct contact with that. So it is entirely different. So don't be mistaken by Rankin formula and the Rankin theory. So in theory of failure, one question will be what is Rankin's theory? In column and thread, they may ask explain Rankin formula. Since both are in same module, you may get confused. That's why I'm explaining one is Rankin formula and another one is Rankin's theory. And when we are discussing, first of all, we must know what are the factors for failure. Whenever a component or a device or anything may fail, there may be 5 reasons. You can see that due to stress, strain, and energy, all accumulating, you will get 5 failing factors. Please note down. There is the theory of failure in the heading. Then you have to write every shaft, every shaft and other mechanical equipments and other mechanical equipments fails due to following factors. Fails due to following factors. All these things are known to you actually. Whenever you are discussing stress, you know that principal stress or normal stress is there as well as shearing stress is there. As we have known that for a 2-axial load, there will be sigma x and sigma y. And if you know sigma x and sigma y, you can calculate principal stresses. That is sigma 1 will be, that is sigma 1 is the principal stress, sigma 2 is another principal stress, and we have another principal stress in a tensor, stress tensor as sigma 3. You know how to calculate all that things, how to calculate sigma 1, sigma 2, and sigma 3. If that is only a biaxial, probably your question will be biaxial problem. You have to calculate sigma 1 and sigma 2. For that, you can either use direct formula or using Moore's circle. Both you have studied in the previous classes, which is handled by Rahul sir. So you have a small idea or better idea about what is principal stress. And also you have shear stress. The shear stress maximum will be determined by the equation sigma 1 minus sigma 2 by 2. As we know that sigma 1 is equal to, I'm forgetting that relation, that is sigma x plus sigma y by 2 plus or minus root sigma x minus sigma y divided by 2 whole square plus tau xy whole square. I think that equation known to you, just for a remembrance. When I am telling that one, that will come in your mind. That's why I explained that thing. By that formula only, we are determining principal stresses. And shear stress also very known to us. And when applying tension or compression, normally the stress will be principal stress, and shear stress will be act in the tangential direction to principal stresses. as well as when you are studying ductile materials and brittle materials, all are comes with these parameters, that is principal stress and shear stress. And we have strain is there. Normally strain is taken as epsilon, that is principal strain. That also may be a reason for failure of the shaft or other components. And we have energy failure also there, stress strain as well as energy failure. For finding energy failure, we have different theories. That is, first one is maximum strain energy theory. We have strain energy equation. We have discussed in the fourth module that what is strain energy and how to calculate strain energy, what are the factors affecting strain energy. That may be equations, bending moment, tension, or maybe due to geometry, location, everything will be affecting on strain energy. For that, we have two equations. First one is maximum strain energy equation, and second one is shear strain energy equation. So altogether, by 5 way, there is a chance of failure. And among that, we are going to discuss all these 5 techniques and which are known as theories of failure. First theory will be based on the first word, that is principle or normal stress theory, or this theory is also known as Rankin theory. Very important point. This theory also known as Rankin theory. And second theory is as known on second one is shear stress theory. That is, second one is shear stress theory. It is also known as Guest theory or Coulomb theory or Tresca theory. Normally, they will ask Guest theory or maximum shear stress theory. And after that, not take this one. The next point will be strain. As we have discussed, strain. So, maximum strain theory will be the third one. And after that, you need to focus on two energy equations, that is distortion energy theory and maximum total strain energy theory. Okay, when comparing with the previous slide, these first two theories are explained as maximum principal stress theory and maximum shear stress theory. And third one is principal strain theory, or that will be maximum strain theory. And last two theories are maximum strain and theory and shear strain theory. That two are mentioned as maximum total strain energy theory as well as distortion energy theory. So these are the basic theories of failure. We need to study all of these things. Have you written this one? We have just mentioned failures factors, and first one is stress. Among that, there will be sub column as principal stress as well as shear stress. Second one is strain, in which the term will be principal strain. And third one is energy, in which two energy theories are there. One is maximum strain energy theory, and second one is shear strain energy theory. Shear strain energy theory. Can you hear me?
Yes, sir.
Which slides shows you? Slide is not changing.
Change ആവുന്നില്ല. Stress strain energy അതാ കാണിക്കുന്നത്.
Okay, 1 minute.
Factors.
Wait. I am connecting my laptop. Please wait. Okay, now you can see these are the failing factors. When I am reading this one, the slide was not shown to you. I have seen the difference in slide, that's why I asked you. So these are the failing factors. Have you written these things?
No, sir.
Okay, we have defined that what is failure. So after that, first one is stress. Subheading ആയിട്ട് എഴുതുക principal stress. ഇതെല്ലാം എഴുതിയെടുക്കുക അതിന്റെ താഴെ നമ്മൾ നേരത്തെ എഴുതിയതിന്റെ താഴെ. Have you completed? Can I change the slide?
Okay, sir.
Thank you. So you must write different theories of elastic failure. The next heading is different theories of elastic failure. Different theories of elastic failure. Different theories of elastic failure. In which first one is maximum principal stress theory. Maximum principal stress theory. Bracketly Rankin's theory. Maximum principal stress theory bracketly Rankin's theory. Maximum principal stress theory bracketly Rankin's theory. Then second one is maximum shear stress theory. Maximum shear stress theory. Maximum shear stress theory bracketly Coulomb, Tresca and Guess theory. These three are different words, that is Coulomb theory will be there, Tresca theory will be there and Guess theory will be there. They will ask either of these terms in your question paper. Most commonly they are using Guess theory. And you must understand by reading that this is the maximum shear stress theory. And if you are not aware about these terms, you will be get confused while in the examination hall. Even though you know the equations, you cannot solve this one because you don't know the word guess theory. So this is very important. So write down maximum shear stress theory bracketly Coulomb theory, Tresca and guess theory. Coulomb, Tresca and guess theory. Coulomb, Tresca and guess theory. Third one, don't write distortion energy theory. Third one is maximum strain energy theory, maximum strain theory. Third one, maximum strain theory. It is nothing but just according to the terms we have mentioned in the last slide, I am writing this one. If you mix this one, you will not understand what is in the last slide. So third one is maximum strain theory bracketly Sen Venance theory. Bracketly Sen Venance theory. Sen Venance theory. Sen Venance theory. Sen Venance theory. And fourth one, distortion energy theory. Distortion energy theory. Distortion energy theory. Distortion energy theory bracketly Huber, von Mises and Henke's theory. Huber, von Mises, and Henke's theory, commonly known as von Mises theory. Huber, von Mises, and Henke's theory, commonly known as von Mises theory. I am explaining it because in your lab, whenever you are going to lab, in the S6, you have analysis lab. Probably all the results showing in your ANSYS workshop or SolidWorks software are von Mises stress. That will be written at the bottom that this is belongs to von Mises stress. So it's an important term while you are doing in a lab. So you must be remember with all these terms. Distortion energy theory, which is the von Mises stress theory, or bracket is the Huber, von Mises, and Henke's theory. And finally, maximum total strain energy theory. Maximum total strain energy theory, or it is also known as maximum strain energy theory, bracketly Hayes theory. Hayes. Maximum total, actually that's wrong. Maximum strain energy theory, total വേണ്ടാട്ടോ. Maximum strain energy theory അല്ലെങ്കിൽ total strain energy theory എന്ന് പറയും. ഒരു ബാർ ഇട്ട് വെച്ചാൽ നല്ലത്. Maximum strain energy theory ബ്രാക്കറ്റിൽ Hayes theory. Hayes theory. Okay, hope you have completed this slide, and we are going to the first method, that is theory of failure. The first theory is maximum principal stress theory. Okay, it is a very important term. Normally it is found using the relation sigma 1 is equal to sigma yield or sigma ultimate. That is, we know that for a ductile material we are having yield strength, but for a brittle material we are not having any yielding. We will directly fail the material once we are applying a load. There is a difference between ductile material as well as brittle material, and hope you have drawn both material properties in your notebook as in the first or second module. I have seen someone have read or drawn the same diagrams in the first series examination. So that's why I'm telling you that for a ductile material, there will be a yield point, but it will not be available for a brittle material. ഓർമ്മയുണ്ടോ ആ സ്ലൈഡ്? ഐ മീൻ ആ മെറ്റീരിയലിന്റെ പ്രോപ്പർട്ടി. ജസ്റ്റ് ഐ വിൽ ഷോ യു വൺ തിങ്. ദാറ്റ് ഈസ്, ഇങ്ങനെയാണ് ഗ്രാഫ് എങ്കിൽ ഫോർ എ ഡക്റ്റൈൽ മെറ്റീരിയൽ ദാറ്റ് വിൽ ബി ലൈക്ക് ദിസ്, ആൻഡ് ഫോർ എ ബ്രിട്ടിൽ മെറ്റീരിയൽ that will be like this. So only for ductile material we are getting yield point. That will be two yield points, upper yield point and lower yield point. And for a brittle material we are not getting any yield point. Directly the most highest value will be ultimate load. Here we can see ultimate load only. So this is the difference between ductile and brittle material. This is not required in this slide. Actually I have drawn this one because you need to know what is brittle and ductile material. That's why we have two principal stress theory equations. First one is sigma 1 is equal to SYT എന്ന് എഴുതും, അല്ലെങ്കിൽ sigma YT എന്ന് എഴുതും. Okay, sigma Y means sigma yield അഥവാ stress at yield എന്നുള്ളതാണ് sigma Y. S എന്ന് പറഞ്ഞാൽ stress എന്നുള്ളതാണ്. You can use either sigma or S. Commonly we will use sigma. So you can write sigma YT. And what is T? Can you guess what is that T? That is one kind of test. I am asking you, have you done any material testing in your S3 lab?
Yes, sir. The universal.
What are the tests you have performed? Universal. Baki. The same testing is written here, that is tension, right? Okay, this is sigma YT means, or SYT means stress is normally denoted by sigma or S, and Y means yielding, and T means tension. Normally a ductile material fail in tension not in a compression mode. Whenever we are applying a compressive load, that won't fail. So T is the tension. And in a brittle material, same way, sigma will be stress or S will be the stress, and ultimate stress will be marked as U, and tension will be marked as T. These are the two equations, and the important criteria is we have three principal stresses. As we have studied, if we are three axial stress occurs in a body, we will be having sigma 1, sigma 2, sigma 3. And if this statement occurs, that is sigma 1 is the largest one, then sigma 1 must be equal to sigma yt. That is, if sigma 2 is the largest one, automatically sigma 2 must be the equation. But we know that for a biaxial theory itself, sigma 1 will be the maximum one. Normally, it will be the statement, we will not get sigma 2 or sigma 3 higher than sigma 1. If we get in a problem, sigma 3 is the highest one, you have to substitute this one as sigma 3 equal to SYT or sigma YT. Okay, it is the important one. Normally, this Rankin's theory is shown as a diagram including sigma 1 in x-axis and sigma 2 in y-axis. This is a biaxial system. There will not be any sigma 3 in this figure. If we draw a cube or rectangular block with sigma 3, then you can understand the third direction. And you must be aware that this theory is mostly applicable for brittle materials. Very important one. Principal stress theory is mostly applicable for brittle material. Okay. Whenever we are taking this in my consideration, this theory is most applicable for brittle materials. So write down, heading is maximum principal stress theory. Heading maximum principal stress theory. Maximum principal stress theory bracket Rankin's theory. Bracket Rankin's theory. The failure of mechanical component. The failure of mechanical component. The failure of mechanical component subjected to biaxial or triaxial stresses, biaxial or triaxial stresses, biaxial or triaxial stresses occurs when the maximum principal stress reaches maximum principal stress reaches the yield or ultimate strength, the yield or ultimate strength of the material. Yield or ultimate strength of the material. If sigma 1 greater than sigma 2 greater than sigma 3, if sigma 1 greater than sigma 2 greater than sigma 3, sigma 1 greater than sigma 2 greater than sigma 3, then according to maximum principal stress theory, sigma 1 is equal to sigma yt. Sigma suffix it yt. Sigma 1 is equal to sigma yt or syt bracket for ductile material. For ductile material. For ductile material. Next line sigma 1 is equal to, next line sigma 1 is equal to sigma ut or SUT, sigma ut or SUT bracket for brittle material. For brittle material. Or brittle material. This theory is applicable for both ductile and brittle material. This theory is applicable for both ductile and brittle material. This theory is applicable for both ductile and brittle material, but it is best suitable for brittle materials. But it is best suitable for brittle materials. But it is best suitable for brittle materials. We'll draw all together. After drawing all the 5 theories of failure, we will draw all the figure. But just remember this figure, that for a Rankin's theory, that will be in a rectangular shape. Okay. After that, we will directly go to a problem with Rankin's theory. Just look the problem and you have to write the problem. That is, please note down, at a critical point in a component, at a critical point in a component, at a critical point in a component, at a critical point in a component,
ഫിഗർ വിളിക്കണ്ട.
ഫിഗർ വരക്കണ്ട, അവസാനം നമ്മൾ ഒന്നിച്ച് വരക്കിത് 5 തിയറിയും കഴിഞ്ഞിട്ട് 5 തിയറിയും കൂടെ ഒന്നിച്ചിട്ടുള്ള ഒരു ഫിഗർ ആയിരിക്കും. ഇത് ജസ്റ്റ് റിമെമ്പർ ചെയ്താൽ മതി ആ ഫിഗർ. Okay. I will show after completing all 5 theories of failure. So probably tomorrow or day after tomorrow, we will draw all together. Okay. So write a problem. Please write down the problem. I will read the question paper for you, and you have to note all these points and write down the given data from the available question. At a critical point in a component, at a critical point in a component, at a critical point in a component, comma, the state of stress is given as, the state of stress is given as, the state of stress is given as sigma xx equal to 100 megapascal, sigma xx equal to 100 megapascal, sigma yy, actually that's not sigma xy, that is sigma yy. Sigma yy equal to 220 megapascal. Sigma yy equal to 220 megapascal. Sigma yy is equal to 220 megapascal. Sigma xy equal to sigma yx equal to 80 megapascal. Sigma xy equal to sigma yx equal to 80 megapascal. 80 megapascal. And all other stress components are 0. And all other stress components are 0. And all other stress components are 0. The yield strength of the material is the yield strength of the material is the yield strength of the material is 468 megapascal, 468 megapascal. Then find, അങ്ങനെ എഴുതണ്ട, then find factor of safety on the basis of, then find factor of safety on the basis of maximum normal stress theory. Factor of safety on the basis of maximum normal stress theory. Factor of safety on the basis of maximum normal stress theory. In the question paper, they have asked Rankin's theory. As we can read that maximum normal stress theory, or it is also known as maximum principal stress theory, or it is also known as Rankin's theory. So it's an important term. That's why I have mentioned this maximum normal stress theory, or it is also known as maximum principal stress theory. So first identify what is the material, whether it is a brittle material or a ductile material. Can anyone answer? Whether it is a ductile or brittle material. Can you identify by seeing the problem whether it's a ductile material problem or brittle material problem? You have already studied all these things. That's why I asked you. Tell me.
Brittle material.
And that you have logically thought because this is asked the maximum normal stress theory and it is best suitable for brittle material. That was a good thinking, but actually there is a yield strength given. You can see that the yield strength of the material is given. Whether brittle material having any yielding? No, right? So for 468 for a ductile material. This is the method to identify the material is whether brittle or ductile. You must identify this thing because whenever you are going to a job, they will give a problem. And if you are not identifiable because of lack of knowledge or lack of concentration, that may lead to errors. So be prepared. That is yield strength is given, so the material is ductile, but they have asked for a maximum principal stress theory. And sigma xs is known to you, sigma xy is known to you, sorry, sigma yy. Actually, it's not sigma xy. Sigma xy is given here. Sigma yy is given to you. Sigma xy equal to sigma yx. This term is normally not denoted as sigma. It is commonly denoted as tau. Actually, xy coming means that's a shear stress. So this is tau xy equal to tau yx. Whenever in a problem, in any module, in any subject, if they are giving sigma xy, then that will be shear stress. Or you can mention it as tau xy. It's an important thing. You should remember this one. And you have to write the given data from the question. And you are writing the given data, you have sigma xx can be taken as sigma x itself, that is 100 megapascal. Sigma y can be taken as 220 megapascal. And tau can be taken as 80 megapascal. Actually, this is tau xy. Okay. Yield strength is given as 468. If you mark it as sigma y, there will be a chance of error. You will be get confused with this term. So always write sigma yt. As we have mentioned, sigma y will not be thus, that will be sigma yt. Sigma yt. Else you will be confused with axis y as well as yielding because both are y. So they have asked you the factor of safety. Okay. For that, first of all, we must find principal stresses For that you have equation sigma 1 is equal to sigma x plus y divided by 2 plus 1 by 2 root sigma x minus sigma y square plus 4 into tau square. This equation to you is known to you, and if you want to find the sigma 2, definitely instead of here plus that will be minus. Please substitute the values, that is sigma x is given, sigma y is given, tau is given. Please substitute the values and find the value for sigma 1 and sigma 2. Find the values for sigma 1 and sigma 2. All the values are given. I will not show you the answer until you find it by calculator. But we are having only less time. So I will show you the answer. Just do the calculation. That is 160 plus or minus 100. So automatically sigma 1 will be 260 megapascal and sigma 2 will be 60 megapascal. Please check with your calculator. There may be error. I have copied from somewhere. So I have edited this one. So there may be chance of errors. So find the exact value. Sigma 1 will be 260 and sigma 2 will be 60. And according to maximum principal stress theory, we know that maximum of sigma 1, sigma 2, sigma 3 should be equal to sigma yield. There is no term factor safety given, so we will take it as equation sigma 1, sigma 2, sigma 3 maximum is equal to sigma yt divided by factor of safety. Again, slide issue. Please find the values. Actually, there is an error of system. That's why my computer got disconnected. One minute. We will do the calculation in the next class. Cannot connect to the next actually. Please put your attendance. We will discuss in the next class at 3 p.m. So please put your attendance now.